part. So how you will use the expression of energy, mainly when you have the some rigid body is there, or something compound pendulum type of system is there. So let's try to go for some more problem, and then we will try to go for how to write the expression of angular momentum also. So these all are well connected to each other. So you can just apply the basic formula, and then you can easily go for the problems. So let's try to go for the problem which I have given you in a homework. So I hope you have attempted this thing. Attempt kiye the. So this is your some hoop, and whose mass is m and whose radius is r. The mass is distributed uniformly to a circumference, and this is just confined to move in xy plane. So this is just confined to move in xy plane, and there is a vertical plane. So this is my vertical plane. So what will happen? So if we are going to disturb it, it will have this sort of position, isn't it? If I will just disturb it, then obviously this will be my new center at some instantaneous point of time, and I can say this angle is theta. Can I write something like this? Isn't it?
Yes, sir.
Can you visualize the whole thing? Okay. And now we have to first write the total energy of a system, and then we can write the equation of motion from total energy also. You can use the torque equation and all this thing, but I am just using the energy part here. So what is total energy? The total energy is again kinetic energy plus potential energy, and the kinetic energy is nothing half m velocity of center of mass square plus half ICM omega square, and we have to just go for writing the potential energy. So potential energy, we will write it separately. Let's say what will be that one. Now, how we will start it? We will just put this point as my origin, and this is the coordinate of center of mass. And let's say this coordinate is nothing, let's say x and y. So first we will write each and everything in a Cartesian coordinate, and then we will see which type of constraints are there and which type of thing is there. We can easily use this thing. So this will be half m, and we can easily write x dot square plus y dot square plus half. What is ICM? What is moment of inertia?
MR square.
Of the ring is obviously mr square. Obviously the axis is this one, so we are just using this particular thing, mr square omega square. And what will be v? So if we are talking about the potential energy, we have to convert all thing in a very simple pendulum, and this pendulum has length r and mass m. Okay, because you can, for the potential energy, you have to just see how your center of mass is going to deviated in a basically gravitational field. So we have to just go for this, and this value is equal to nothing but m, and this value is negative because I can choose this one is my positive, this one is my 0, and this one is my lower energy. So I can just go for mgy. Now, what is equation of constraint here? What is equation of constraint here?
Z equals to 0.
Obviously, one is z is equal to 0. So we have used this thing at z is equal to 0. What is another equation of constraint?
X minus 0 whole square plus y minus 0 whole
Exactly. So this center of mass is moving in a circle where you can write, obviously this is x minus, not, so this is x square plus y square is equal to what? R square, isn't it? So this is your basically equation of constraint. So every time x and y have relations such that it is moving in r square. So in which coordinate system we have to move? If this is your equation of constraint, then obviously we have to move into what? Circular
Circular.
polar coordinate. So I can write x is equal to what? R sine theta. Y is equal to what? R cos theta. And from here we can put x dot is equal to R cos theta, theta dot, y dot is equal to minus R sine theta, theta dot. So we can put it here. And what is your omega? Omega is nothing but actually theta dot. So I can write this value. That value is half m r square theta dot square plus half m r square theta dot square minus mg. And what is value of y? Is nothing but r cos theta. And the whole total energy of a system is given by mr square theta dot minus mgr cos theta. And obviously we know the total energy of system is conserved. So if it is conserved, you can easily use dE upon dt must be equal to 0, which implies 2m r square theta dot theta double dot, and we can just go for minus minus plus mg r sin theta theta dot must be equal to 0. है ना? दिखाई दे रहा है? So
सर एम आर थीटा डॉट स्क्वायर आएगा ना, E इज इक्वल टू
कौन सा? ये
एम आर स्क्वायर थीटा डॉट स्क्वायर आएगा ना
कहाँ पर?
नीचे ई का जो हमने
Okay, yes. I have differentiated here. Don't worry. So in my mind there is theta dot square, but I have written theta dot. Okay, thank you. Yes. ठीक है ना यहाँ पर? So what will happen? Which quantity I can take common? I can take m r square theta dot I can take common, and we have theta double dot plus g upon, and you can take 2 also common, g upon 2r sine theta must be equal to 0. You can take 2mr square and theta dot common. This, so g by 2r will be there. So this quantity cannot be 0. Okay. So this is equal to not 0. So this quantity have to be 0. And what we will get? We will get theta double dot plus g upon 2r sine theta must be 0. And this is nothing but my equation of motion. So you can see how we can move from energy to equation of motion. Energy के through equation of motion में हम कैसे जा सकते हैं? Isn't it? And for the small angle, you can write theta double dot plus g upon 2r theta must be equal to 0. So what will be value of omega? Angular frequency for the small oscillation?
Root under
G upon 2r. Okay. Simple problem, straightforward problem, but each and every concept is there. Now, in this type of problem, some people can take the moment of inertia about this axis also, and that will be also true. Why? Because the distance of center of mass and the point of position is not going to change. And this is the condition of pure rotation. So when you have rolling without slipping or you have pure rotation, you can take the moment of inertia about point of position. But when you have different circumstances, then you have to worried about this. So why deliberately I have written this one? Because this will work for each and every problem. Either it is pure rotation or it is not a pure rotation, just a different condition. You can use it. So let's try to go for more insightful problem and try to see why I am just using this concept, not I am using this moment of inertia about this particular point. Are you people happy?
Yes, sir.
सर
Mm-hmm.
मतलब यहाँ हमने z एक्सिस के अलोंग सेंटर ऑफ मास का एक्सिस लिया है ना, मतलब अभी आपने जो स्टेटमेंट बोला वो समझ में नहीं आया, मतलब x
मैं ये
एक्सिस के
बोल रहा हूं, समझने की कोशिश करो कि आप चाहो तो इस पॉइंट के अबाउट भी मोमेंट ऑफ इनर्शिया ले सकते हो और इसको प्योर रोटेशन एज्यूम कर सकते हो। आर गेटिंग माय पॉइंट?
ओके,
अगर प्योर रोटेशन एज्यूम करोगे देन व्हाट विल हैपन? मोमेंट ऑफ इनर्शिया उसके अबाउट क्या होगा? हाफ। बताओ इसके अबाउट क्या होगा मोमेंट ऑफ इनर्शिया? फर्स्ट
हाफ एम आर स्क्वायर।
हाफ mr स्क्वायर, मोमेंट ऑफ इनर्शिया अबाउट सेंटर ऑफ मास, ठीक है ना? और प्लस यू विल गो फॉर पैरेलल एक्सिस थ्योरम, यूज करोगे?
m/2 का होल स्क्वायर।
r/2 क्यों भाई? ये रिंग है ना,
Oh
ठीक है?
yes, mr.
mr स्क्वायर इज सेंटर ऑफ मास के अबाउट, इस पॉइंट के अबाउट क्या होगा? पैरेलल एक्सिस थ्योरम यूज करो, क्या हो जाएगा?
2mr
mr स्क्वायर। सो दैट यही होगा ना मोमेंट ऑफ इनर्शिया।
yes sir
I about O, don't worry. And this I and half is not there. This will be just 2 times mr square. And you can write your kinetic energy half 2 times mr square theta dot square. Clear है ना? Are you getting my point? अब यहां पे देखो क्या मिल रहा है आपको, इन दोनों से सेम मिल रहा है आपको, जस्ट चेक इट। Is that you are getting the same answer?
Yes, sir.
Yes या no? यहां पर हमने क्या किया? यहां पर हमने जो मोमेंट ऑफ इनर्शिया है वो पॉइंट ओ के अबाउट ले लिया, एंड इफ आई एम टेकिंग द मोमेंट ऑफ इनर्शिया पॉइंट ओ, देन आई हैव टू राइट हाफ आई ओ एंड प्योर रोटेशन, so there is not any translation motion about this point, so this will be half io omega square. So either you can choose this one or you can choose this one, you will get the same answer when the case is for the pure rotation. Are you getting my point? समझ में आ रहा है मैं जो बात बता रहा हूं? बहुत से बच्चे गलती करते हैं इसके लिए। When I will solve the next problem, then I will tell you where is the real problem comes there. ठीक है, चलो नेक्स्ट प्रॉब्लम सॉल्व करते हैं और तो जरा समझने की कोशिश करते हैं कि मैं क्या कह रहा था। राइट नाउ दिस इज द केस ऑफ प्योर रोटेशन because the distance of point of position and the center of mass is not going to change. So this is at the constant distance. So you can use either this formula or you can use either this formula. There is not any problem. लेकिन प्रॉब्लम कहां होगी वो हम जरा देखने की कोशिश करते हैं, ठीक है? ओके और ऐसे क्वेश्चन TIFR के एग्जाम में खूब आते हैं, है ना? देखिए, लेट्स ट्राई टू गो फॉर दिस प्रॉब्लम। इस प्रॉब्लम को देखो, फिर हम इसको समझने की कोशिश करेंगे कि कहां हम क्या गलती कर रहे थे। ओके, लुक एट दिस वन इज वेरी इंटरेस्टिंग एंड दिस वन इज वन ऑफ द माय फेवरेट प्रॉब्लम। सपोज देयर इज a spring and the length and the spring constant is k. The original length of a spring is, let's say, L naught, and there is a rod attached to this particular spring and whose length is L, mass is m, and this rod can move in vertical axis. Suppose it is moving in vertical xy axis. Suppose this is your z axis, so you can say this is my x axis, this is my y axis, and this will be my g. Okay, now what will happen? This spring will come up and down and this point will rotate, something like this, isn't it? ऐसा ही होगा ना? Due to this spring, this point will go up and down, and this will just going to rotate. So I can take this angle is theta because it is rotating about this point, and this is my origin. Now, where is the center of mass? This is my center of mass. So I can put it this value as xcm and ycm. And let us assume at some particular moment, this point is x. This point is x. And please, this point is not fixed. This point is moving. Sorry, this point is y. Just put it y. This point is y. And this point is actually moving up and down. And now look at this particular problem. This is very interesting. So in this case, this rod is not doing the complete rotation. It will be just doing something like this, isn't it? ऐसे ऐसे करके इसका motion हो रहा है. So in this case, how you will approach the problem, and then we will find where the people are doing a very conceptual blunder. Okay. So let's try to go for only kinetic energy. What is your kinetic energy? The kinetic energy here is what? क्या लिखें kinetic energy? Half m VCM square plus half ICM omega square. Clear है ना?
Yes, sir.
And what is your VCM? That is xcm dot square plus ycm dot square plus what is your ICM? ICM क्या होगा आपका?
ml square by 12.
ml square by 12. And what is your omega? Is nothing but theta dot square. Yes? Every point of this particular rod is moving with the same angular velocity. Now, the next step is very interesting. What is the equation of constraint here? What is the equation of constraint here? Can I write xcm is equal to L sin theta? Your distance, sorry, L by 2 sin theta, isn't it?
Yes, sir.
This distance. And what is your YCM?
Y plus
By 2 cos.
Exactly, y plus L by 2 cos theta. And now we have to calculate what will be my x dot cm. So that value is L by 2 cos theta, theta dot. And what is your YCM? YCM is equal to y dot minus L by 2 sin theta, theta dot. Everyone is comfortable? And now if we are going for the x dot cm square, y dot cm square, that means just you can take a square plus b square minus 2ab and plus, let's say this is your c square. Or you can just put a here, b here and c for this. So can I write, just check it whether I am correct or false. Half m. So this square plus this square. First, y dot square will be always there. Yes or no?
Yes, sir.
And you have this square plus this square is equal to what?
2 square.
L by 4 theta dot square. Yes. And the cross term is also there. Yes, क्या हो गया?
L square, sir.
हाँ, L square. Okay. And the cross term is there. 2bc minus sign. This will be minus 2 y dot L by 2 sine theta theta dot and plus half ml square by 12 theta dot square. Now look at this particular expression very carefully. Look at here. This term and this term is going to add it. So I have half m y dot square plus half m L square by 3 theta dot square minus half m, this 2 and 2 will cancel out. So this value is equal to y dot L sine theta theta dot. Now look at this is your expression of kinetic energy. Everyone is comfortable here? And now if some people will take this blunder and he will take moment of inertia about this point. Are you getting my point? You can write half my square. Okay, there is some vertical changes is there, so this will be okay. Anyone can write this thing. And if you are taking the moment of inertia, the pure about this particular point, then obviously you will get this one. But how you will get this one? Are you getting my point? आप समझ रहे हो मैं जो बात कह रहा हूं?
Yes, sir.
So here, if someone will take the pure rotation about this point, that will be wrong. Because this point is itself moving in a vertical direction. Are you getting my point? जैसे मैंने जो फर्स्ट क्वेश्चन किया था उससे मैं आपको कंपेयर कर रहा हूं. Suppose there is a rod and this point is fixed. So what will be moment of inertia about this point? What will be kinetic energy? I can write my kinetic energy as first expression is half VCM square plus half ICM omega square. ऐसा लिखा था ना? याद है फर्स्ट क्वेश्चन जो हमने किया था?
Yes.
हाँ किया था इसे?
Yes, sir. Yes.
तो उसके थ्रू क्या आया था? यही आया था ना, हाफ ml स्क्वायर बाई 3 इंटू थीटा डॉट स्क्वायर. यही तो आया था.
Yes, sir.
याद करो लास्ट क्लास में जो फर्स्ट क्वेश्चन किया था हम लोगों ने, यही आया था ना?
Yes.
ओके. और अगर आप इस पॉइंट के अबाउट मोमेंट ऑफ इनर्शिया लोगे तो कैसे लोगे? हाफ, suppose you are doing the moment of inertia about this point, that means you are assuming that this rod is doing pure rotation about this point. So what will be this particular value? ml square by 12, this is about center of mass, plus m
Square by
L square by 4, you will get, and that is your theta dot square. So that value is same thing, ml square by 3 theta dot square. So either you will take this expression, please mind it. Now you can listen very carefully. In this problem, either you will take the expression of kinetic energy half m VCM square plus half ICM omega square is equal to half IO omega square. Are you getting my point? आप ये एक्सप्रेशन लो या ये एक्सप्रेशन लो, ये दोनों ही एक्सप्रेशन आपको क्या दे रहे हैं? सेम वैल्यू दे रहे हैं ना काइनेटिक एनर्जी के.
Yes, sir.
यस या नो?
Yes.
But if you are going for this particular problem, then you cannot take the moment of inertia pure rotation about this point, because this point is moving up and down. So if you will take the pure rotation, you can take this one, it's okay. You can take this one also, but how you will get this one? There is some extra energy term for the extra kinetic energy term for the center of mass. Are you getting my point? So in this case, can you take this expression? T is equal to half IO omega square. क्या ये एक्सप्रेशन यहां ले सकते हो इस प्रॉब्लम के लिए?
No, sir.
नो सर, नहीं ले सकते।
नहीं ले सकते हो। तो अब ये मुझे ये बताओ कि हमेशा हमें ये एक्सप्रेशन लेना चाहिए या फिर ये एक्सप्रेशन लेना चाहिए? ये एक्सप्रेशन तो हर एक जगह पर सही है ना?
यस सर।
आर यू गेटिंग माय पॉइंट और नॉट? This expression is correct for either pure rotation or either any case. But this expression is true only in the case of a pure rotation. Are you getting my point?
Yes, sir.
है ना? तो इसी कारण मैं कह रहा हूं कि आपको जब भी एग्जाम में प्रॉब्लम इनकाउंटर करोगे, then obviously go for this expression. ठीक है? And then you will be always correct. So this is one of the very fundamental problem और इसके थ्रू आप कई चीजों को समझ सकते हो। ओके, क्लियर है एवरीवन? एनी डाउट? एनी डाउट? ओके, सो एक क्वेश्चन TIFR में आया था, मैं आपको ये होमवर्क दे रहा हूं, जस्ट ट्राई टू डू दिस वन, है ना? और आप यहां पर सेम चीज लगाने की कोशिश करोगे। ओके, बहुत ही ब्यूटीफुल प्रॉब्लम है, जस्ट ट्राई टू डू दिस वन। देखो क्या प्रॉब्लम था, दिस इज वेरी इंटरेस्टिंग। सो यू हैव वन स्प्रिंग और एक ऐसे रॉड है एंड यू हैव अनदर स्प्रिंग, दिस इज योर सेंटर ऑफ मास, द लेंथ ऑफ रॉड इज L, the spring constant is K, don't worry. Okay, so what you have to do, you have to write the expression of kinetic energy. Okay, you have to write the expression of kinetic energy. How you will write it? And for the small angle, this angle is theta. So this is not given, they are given that this is your x1 and this is your x2. So you have to write the expression of kinetic energy in term of x1 and x2. How you will write this particular thing? कैसे लिखोगे?
Sir, by considering the center of mass again,
Obviously आपका फर्स्ट एक्सप्रेशन क्या होगा बताइए?
half m VCM square plus
Obviously first you will write half m VCM square plus ICM omega square, यही तो लिखोगे ना? And what is your VCM in this case? Anyone? What will be your VCM?
x2 plus x1 by 2 for
Yes, that will be x2 by x1 by 2. So VCM is equal to x2 plus x1 by 2 dot square, isn't it? Why? Because center of mass is just a average displacement. Okay, if and obviously the distribution of mass in this side and distribution of mass in this side is same. So if this point is moving x1, this point is moving x2, then obviously center of mass will be on an average x1 plus x2 by 2. So this is your center of mass. And you have half, what is ICM?
ml square by 12.
Obviously ml square by
12.
12. And you have to just go for theta dot square. Now you have to write the all expression in term of x1 and x2. So you have to replace theta dot from here. So how you will replace theta dot from here? कैसे replace करोगे theta dot को यहां से? So this question was in TIFR. Okay. कैसे replace करोगे? How you will replace it?
Constant equation.
Obviously, what will be constant equation? So this angle can be written as theta, So can I write sin theta is equal to x2 minus x1 by L? लिख सकते क्या?
Yes, sir.
है ना? And for the small angle, I can write sin theta is equal to theta. For a small angle, I can write theta is equal to x2 minus x1 by L. And what will be theta dot? Theta dot, you can write x2 dot minus x1 dot by L. Now you can put it here. And once you will put it here, you will get half m x2 dot square plus x1 dot square. Sorry, x2 dot x1 dot whole square by 2 plus half m L square by 12. And here you will write x2 dot minus x1 dot by L whole square. And now you can easily solve this particular problem. कर लोगे solve? है ना? So it's a very nice answer actually when you will going to solve it. ठीक है? So you just try to find the final answer. But look at, and again, you cannot assume that this particular rod is moving about this point as your pure rotation. This is not a case of pure rotation because this every point is just center of mass is just moving every time that with some particular, it is just moving with the, so if we are taking this as origin, so it will be just changing every time. Isn't it? And this is also moving up and down. This is also moving up and down. So there is not a case of pure rotation. So you cannot take moment of inertia about this point. No, you cannot assume that this is pure rotation about this particular point. Are you getting my point?
Yes, sir.
अगर ये यहाँ fix होता, that is different issue. But it is not fixed. This point is just moving up and down. Same as the last problem. So you have to be very much careful. So don't worry, always try to start from here. यहां से शुरू करके करो. अगर आपका प्योर रोटेशन है तो भी आपका आंसर आ जाएगा. प्योर रोटेशन नहीं है तो भी आपका आंसर आएगा. You have to just use your equation of constraint and the coordinate of center of mass very efficiently. समझ रहे हो मैं जो बात कह रहा हूं?
Yes, sir.
Yes?
Yes.
Okay. So let's go for one more problem. एक और problem करने की कोशिश करते हैं. ठीक है? And this was again for the energy one. देखते हैं आज energy पूरा कर पाते हैं या नहीं. Okay. So are everybody is comfortable? है ना? Because this is really little bit more conceptual. है ना? In general, a lot of people are confusing about the difference between pure rotation and in general case. So you have to always go for the general case. Okay. Okay. So last one, I think this is a little bit lengthy, so we have to just work on each and every point. Now you will see in this problem, I will use the whole concept, the particle dynamics as well as rigid body dynamics to write the expression of kinetic energy. Okay, so let's try to go. We will write the concept of the expression of total energy. This is very interesting. So there is a ring, and this ring has radius r and mass capital M. So there is two mass. One mass is small m, and this small m is very, very less than capital M, such that center of mass will remain there. Okay, otherwise center of mass will shift. So this will be a dangerous thing once your center of mass is going to shift. So, but small m is, and this is some bead. Okay, bead moti hai na? This is some bead, and this bead is freely rotate on this particular circumference of the ring. So this bead will move on a circumference of ring. Obviously, this is my x-axis and this is my y-axis. This is my x-axis. So what we have to do, we have to write the expression of kinetic energy as well as expression of potential energy in this particular system. Okay? So how you will go for this? So I will just put this as my origin. है ना? So here you have rigid body as well as particle dynamics. You have capital mass m as well as a small mass. So for this particular point, I can put the coordinate is xcm and ycm. लिख सकते ना? This is my coordinate xcm plus ycm. और x एंड y पुट कर लो, उसको x1 y1 दे देंगे. ठीक है, बार बार cm लिखने की जगह पर x and y. Can I write this coordinate here? Yes. And I can write the coordinate of this particular mass is, let's say, x1 y1. So here you have to write the total energy of a system. So total energy of a system is equal to kinetic energy plus potential energy. So here we have to go for kinetic energy for a ring also as well as for a mass also. Okay. So what will be kinetic energy for a ring? क्या होगा रिंग के लिए? क्या एक्सप्रेशन लिखे?
half m VCM square plus
Obviously you will just go for half m VCM square plus half ICM omega square. And there is another information that this ring is executing the condition of rolling without slipping. So ring is executing the condition rolling without slipping. What is the meaning of rolling without slipping?
VCM equals to omega r.
Obviously, that means your VCM is equal to omega r. So this is one condition given. So this is your kinetic energy for what?
The ring.
Ring. And now you have to write the kinetic energy for mass also. So what will be kinetic energy for mass?
Half mv square.
Obviously half m v square. Now, what will be VCM square? I can write this thing will be x dot square plus y dot square, isn't it? And half, what will be ICM?
mr square.
mr square. And what will be omega? अभी omega ही रहने देते हैं. And this will be half m x1 dot square plus y1 dot square. We are writing just kinetic energy expression. Okay, x1 dot square plus y1 dot square. Now, and assume this angle is theta. So it is rotating at some particular point. This angle is theta. Now, what will be equation of constraint here? First constraint is that y is equal to r. Yes or no? Center of mass will always have same vertical distance. It is just moving y is equal to r. Clear है या नहीं? And second is that, can I write x1 is equal to x plus r sin theta? देखो लिख सकते क्या?
Yes, sir.
आया ना? लिख सकते?
Yes, sir.
Yes. And what is your y1?
R cos theta.
r plus r cos theta. ठीक है? And now I can put the value of x1 dot that is x dot plus r cos theta theta dot y1 dot is equal to minus r sin theta theta dot. So we will put, and what will be y dot? Y dot is 0. Now we have to put the all expression here of the kinetic energy. So this value is half m, and what is this particular thing? This value is all about x dot square. इसको अभी ऐसे ही रहने देते हैं, हाफ m r स्क्वायर ओमेगा स्क्वायर plus half m. We have to go for x1 dot square plus y1 dot square. So you have a square plus b square plus 2ab plus c square. You can just assume this is your a, this is your b, this is your c. क्या हो जाएगा बताओ? x1 dot square के लिए क्या होगा?
Sir, x dot square plus
x dot square plus
r square
b square plus c square से क्या हो जाएगा? r square
Theta dot square.
theta dot square plus cross term will be also there. So what will be this value? 2 x dot theta dot r cos theta. दिखाई दे रहा है यार? ये बहुत बड़ी प्रॉब्लम है. क्लियर है ये? Now my challenge is, what is omega? Anybody can tell me what is omega here?
VCM by R.
So what is VCM?
x dot
Sir,
X dot, isn't it? VCM is nothing but what? X dot. So I am just removing
sir,
this part.
y1 डॉट में माइनस r sin थीटा है ना,
हाँ हाँ
तो y1 डॉट स्क्वायर
हाँ,
करेंगे
तो माइनस माइनस प्लस नहीं होगा?
तो जो क्रॉस टर्म है वो sin थीटा आएगा ना.
नहीं नहीं, क्रॉस टर्म तो यहां से आएगा. अरे देखो, ए स्क्वायर प्लस बी स्क्वायर प्लस 2ab एंड सी स्क्वायर. यहां तक क्लियर है?
ओके ओके सर, यस
ए स्क्वायर तो लिख दिया, बी स्क्वायर प्लस सी स्क्वायर ये लिख दिया,
ओके
बाकी तो क्रॉस टर्म में मिलेगा ना. ठीक है, खुद करोगे सब प्रॉब्लम. ठीक है, इतना लंबा प्रॉब्लम नहीं आता एग्जाम में, बट लेकिन इसको करने से क्या होगा, आपको कॉन्फिडेंस आएगा. ठीक है, सो वी हैव टू जस्ट गोइंग फॉर बट TIFR जस्ट नेट टेस्ट में तो ऐसा आ सकता है. देयर इज नॉट एनी दिस, इस तरह के प्रॉब्लम आ सकते हैं. सो व्हाट इज योर काइनेटिक एनर्जी? दैट वैल्यू इज हाफ m. This value is what? X dot square plus half m r square. What is omega square की वैल्यू क्या होगी? Obviously x dot by r whole square. क्या गलती से थीटा डॉट स्क्वायर मत लिख देना. Are you getting my point? थीटा डॉट तो इसका चेंजेस है. So you have to always keep in mind कि कौन सा कॉन्सेप्ट को आप कहां पर कैसे यूज कर रहे हो. ठीक है, and what will be next one? So ये तो हो गया rigid body के लिए, है ना? And then we will go for the particle one. So this will be half m x dot square r square theta dot square. आगे भी बढ़ रहा है, सर्कल में भी जा रहा है, आगे भी बढ़ रहा है, सर्कल में भी जा रहा है. And then there is some mixed term also. So when mixed term is there, that is 2 x dot theta dot r cos theta, and now these two can be added and you will get the very nice form of kinetic energy, m x dot square plus half m.
लास्ट में भी टर्म था ना, r स्क्वायर sin स्क्वायर थीटा थीटा डॉट स्क्वायर.
ये कहां से आ गया?
हाँ सर,
कहां से आ गया ये?
मैं
हाँ?
नहीं सर, सही है आपका, सॉरी. वो cos स्क्वायर थीटा प्लस sin स्क्वायर थीटा.
हाँ, ये करना है ना, ये तो करोगे. ठीक है, मैं तो एक बार में लिख देता हूं ना, क्योंकि मुझे जहां मुझे एक जगह साइन थीटा दूसरी जगह कॉस थीटा मिल रहा है, तुरंत दिमाग में चले जाना है कि भाई तुम्हें तो ऐड होना ही होगा. Isn't it? क्योंकि कहीं ना कहीं सर्कल का तो कंडीशन आ रहा है ना.
हाँ
अगर स्मॉल मास को देखो तो सर्कल का कंडीशन तो आ रहा है, तो सर्कल का कंडीशन तो होना ही होना है ना,
हाँ
एग्रीड और नॉट? ठीक है, सो एक्स डॉट स्क्वायर प्लस आर स्क्वायर थीटा डॉट स्क्वायर प्लस 2 x dot theta dot r cos theta. So this is your kinetic energy, and then you can write your potential energy. What is your potential energy? क्या हो जाएगा? सेंटर ऑफ मास के लिए पोटेंशियल एनर्जी mgr, इसके लिए पोटेंशियल एनर्जी प्लस mg r plus r cos theta. That's it. So you can put it and you can get the answer. ठीक है? So this type of problem can always come into your exam, और आप इस तरह के प्रॉब्लम को हमेशा ट्राई करोगे करने का। ठीक है, कॉन्सेप्ट इज वेरी सिंपल, स्टार्ट फ्रॉम स्क्रैच, स्टार्ट फ्रॉम हाफ m VCM स्क्वायर प्लस ICM ओमेगा स्क्वायर, यहीं से आप शुरू कीजिए, और फिर जो जो कहानी बनते जाती है विद द हेल्प ऑफ इक्वेशन ऑफ कंस्ट्रेंट, यू कैन इजिली यूज ऑल दिस स्टोरी। एवरीवन इज क्लियर है ना? So just try to do all this problem with yourself, है ना? आपके एग्जाम में बहुत टफ प्रॉब्लम नहीं आते हैं, इजी प्रॉब्लम आते हैं इन एनी एग्जाम, आइदर नेट हो, गेट हो, जैम हो, जेस्ट हो, बट यू हैव टू फोकस ऑन द मेन कॉन्सेप्ट। ठीक है, सो टुमारोज क्लास वी विल जस्ट गो फॉर angular momentum, how you will write the expression of angular momentum, and how you will go for expression of torque. ठीक है, बिकॉज वी हैव वेरी फ्यू टाइम, तो नया टॉपिक शुरू करने का कोई फायदा नहीं होगा, है ना? जस्ट ट्राई टू डू ऑल दिस थिंग विथ योर सेल्फ। ठीक है, एंड देन दिस टॉपिक विल ओवर। ठीक है, एनी डाउट? अगर कोई डाउट है तो आप पूछ सकते हो, और कई डाउट्स आए हैं मेरे पास, सो गिव मी सम डे, जस्ट 1 वीक, आई विल क्लियर ऑल द डाउट्स, है ना? मेनली कुछ रूपाली के डाउट्स आए हैं, एक दो और डाउट्स आए हैं। ठीक है, सो आई विल क्लियर ऑल दिस, ऑल आर सिंपल डाउट्स, बट आप कुछ डाउट्स तो ऐसे हैं जो कि मैंने क्लास में भी किए हैं, देन यू हैव टू गो फॉर वीडियो रिकॉर्डिंग और योर नोट्स। ठीक है, बट एनीवे वी विल डिस्कस ऑल दिस थिंग। चलो फिर, गुड नाइट,
Good night, sir.
थैंक यू,
Thank you, sir.
थैंक यू।